Hey guys, it's Ms. Marflack here. We're moving on to our next lesson in trigonometry, and that's working with exact values. We've already spent 2 days on exact values. We've done 0 to 360 degrees, and then we did quadrantal angles, and then we did a little bit of coterminal angles. Like I said in the last video, I know we've been struggling with the coterminal angles. I can see it in our work. So we split this up over 2 videos, and we're going to do some more example problems for coterminals today. And then along with the coterminals, we're also going to be taking a look at negative angles, and then we're going to put them together. We're going to do negative coterminal angles. Just like in our previous videos, this is our honors class, so we're doing degrees and radians for our angles. After today, that's it. We're done with exact values, which means that you're going to have a review for trigonometry and then a test. And your test is going to include everything we've done with trigonometry, our 30, 60, 90, coterminal, reference angle, all the good stuff that we've done with trigonometry. All right, before we get started with this video and this new topic of coterminals and negatives, we do have to recall some things from our previous videos. So throughout this video, we're going to be using our fact that cosine is our x-coordinate and sine is our y-coordinate. We also know that tangent theta is now our identity sine theta over cosine theta, and that's y over x. And then we used this fact that cosine is x and sine is y to help us build this pretty picture here, which tells us where each trig function is positive or negative. We found out in quadrant 1 that all the trig functions are positive. In quadrant 2, just sine theta is positive, every other trig function is negative. In quadrant 3, just tangent theta is positive, every other trig function is negative. And quadrant 4, just cosine theta is positive and every other trig function is negative. And then we're just labeling the quadrants up here using those Roman numerals. And then we also had our quadrantals in both degrees and in radians. And then this picture will help us with most of our practice problems because we use this clean kind of laid out method to solve for the exact value. And first we had to find out what quadrant is the angle in, whether or not the trig function is positive or negative there, then the reference angle, and then we were able to evaluate. Now, along with this beautiful picture to kind of help us out with our practice problems, we also need something else, and that is our 30, 60, 90, 45, 45, 90. Like I said, in our upcoming tests, you will be tested on your knowledge of these two special right triangles. If you can remember, we started off this trig unit with finding the missing side, and there are our two triangles. We're going to just briefly review some practice problems from earlier, and we're first going to start off with finding the exact value, and we're going to do our 0 to 360 degrees along with some quadrantals. So this right now in this green color is, sorry for the small cut in the video, I just got a phone call, but I'm back. Okay, so we were finding the exact value and just quickly reviewing some previous problems from our past 2 or 3 videos. We're going to go over evaluating cosine of 240 degrees. Now, you may think you already know this, okay, but stick around for the video because I just checked your guys' homework and it looked good. I'm always happy. Trig is really difficult. There's a lot of things to keep in mind, but there's a lot of small mistakes with like negatives and maybe the wrong reference angle. All right, so please watch. We're only going to just review a few of them. All right, so we have to identify what quadrant 240 is in. That's going to be in quadrant 3 between 180 and 270. In quadrant 3, tangent is positive, cosine is negative. 240 degrees is 60 degrees away from 180. That's my reference angle. So I do cosine of 60 degrees and I make it negative. Cosine of 60 degrees is adjacent over hypotenuse. That's going to be negative 1/2. Notice how I put the negative with the final answer. A lot of you guys had the correct work but didn't put the negative with the final answer. Taking a look at number 2, let's do sine of 7 pi over 4. All right, it's a little harder to think in the radians, okay, but we have 7 pi over 4. That means we pass 2 pi over 4, 4 pi over 4, 6 pi over 4, and here we are lying in quadrant 4. So it's helpful to get a common denominator with those quadrantal angles. All right, and then 7 pi over 4 is in quadrant 4, where cosine is positive, sine would be negative. And then we have, you can use that beautiful, beautiful, beautiful green sheet that I made for you guys, and pi over 4 denominator is 45 degrees. So your reference angle is pi over 4, which is 45 degrees. So then we evaluate sine of 45 degrees, which is opposite over hypotenuse, and we make it negative. And then our only problem here is that we have that radical in the denominator. This is not simplified, so we go ahead and we rationalize, and we're going to get negative square root of 2 over 2. All right, and then we're just going to review one more together, and that's going to be number 3. We're going to do tangent of 3 pi over 2. All right, and then those bells should be going off in your head that 3 pi over 2 is a quadrantal angle. When you're working with angles that lie in quadrants, we do this method, and then with the quadrantals, we just needed our x, y, and y over x. So tangent is y over x, and then I take a look at 270, and my y value is -1, and my x value is 0, so I do -1 over 0. So y over x, and then we have -1 over 0, and you cannot divide by 0, so this is going to be undefined. All right, and then that was just a quick review of our previous videos. All right, in our last video, we did quadrantal angles like number 3, but then we also did something else, and what we did was begin working with those coterminal angles. Now we're going to pick up a coterminal angles today and just take a look at a few more examples before we hit the negatives. Our directions are still going to be the same, and that's going to be find the exact value. All right, and then while you're working with those coterminal angles, you can definitely use a calculator. And here we are, number 1, we have cosine of 510 degrees. All right, so I take a look at 510 degrees, and I see that that is past 360 degrees. So I want to first start off by solving for a coterminal angle. So I'm going to subtract 360 degrees to find an angle from 0 to 360 degrees that'll have the same exact value. So 0 minus 0 is 0. We regroup or borrow from the 5, 11, 5, and a 1. All right, you can use a calculator for that. And then what we're going to see here is that cosine of 510 degrees is going to be the exact value of cosine of 150 degrees. They're coterminal, they share the same initial and terminal side, and they're the same angle in the same place, just on different revolutions. So we could do cosine of 150, which we know how to do, and 150 is in quadrant 2, where sine is positive, so cosine is negative. And then 150 is 30 degrees away from 180, so we do cosine of 30 degrees and we make it negative. Cosine of 30 degrees is adjacent over hypotenuse, and that answer there is going to be negative square root of 3 over 2. And then I'm just going to box in our answer here because we got a lot of scrap work. So cosine of 510 degrees is negative square root of 3 over 2, and cosine of 150 is negative square root of 3 over 2. All right, we're going to take a look at number 2, finding the exact value. We have sine of 19 pi over 6. Here's another example of a coterminal. We're past that one revolution of 2 pi. So just like over here where we subtracted 360, we're going to have to subtract a revolution from the angle 19 pi over 6. But now we're working with radians. So one revolution is 360 degrees, which is 2 pi. So I want to subtract 2 pi here, but I need a common denominator. So 2 pi is 12 pi over 6. And then when you subtract, you should see that 19 pi over 6 and 7 pi over 6 are the same angle. They're coterminal. So I know how to evaluate sine of 7 pi over 6, and it's going to be equal to this exact value. So now we're working with this problem here, and 7 pi over 6 passes 6 pi over 6 using those common denominators, which means we're in quadrant 3. In quadrant 3, tangent is positive, sine is negative. And then our reference angles, our denominator here, that's how far away we are from that x-axis, and that's pi over 6. Now, if you're not too comfortable with radians yet, that's okay. Go back to your reference sheet. Pi over 6 is 30 degrees. All right, so I create pi over 6 and 30 degrees. So we're going to do sine of 30 degrees and make it negative. Here we are at 30 degrees. We have opposite over hypotenuse, and our final answer here is going to be negative 1/2. And then boxing it in because I got a lot of scrap work there. All right, so sine of 19 pi over 6 is equal to negative 1/2. Moving on to number 3 here, we're going to take a look at a tangent example. tangent of 1020 degrees. Whoa, that's a big number. You can definitely tell that that's greater than 360. So let's get started here by subtracting a revolution. You can definitely use a calculator here. I'm going to regroup the 10 to a 9, regroup the 2 to a 12. We have 6 and then 6 here. And then 660 degrees is still past 360. So I need to subtract another revolution so that I can evaluate this problem. So we're going to subtract here and we're going to get 300 degrees. So tangent of 1020 degrees is the same as tangent of 660 degrees, which is the same as tangent of 300 degrees, because those three angles are coterminal. But now we know how to evaluate this from previous videos, and we know 300 degrees in quadrant 4, where cosine is positive, tangent is negative, and we're 60 degrees away from that x-axis. So we're going to do tangent of 60 degrees and make it negative. I saw a lot of mistakes with tangent of 60 degrees and tangent of 30 degrees, so pay attention here. Tangent is opposite over adjacent, so we have square root of 3 over 1. And then we're going to make it negative. And square root of 3 over 1 is just square root of 3. All right, we're going to do a few more together. And here we are. We're going to take a look at cosine of, we'll do 8 pi over 3. Cosine of 8 pi over 3. All right, so you should be recognizing that 8 pi over 3 is past 2 pi, so I need to subtract a full revolution. I'm going to subtract 2 pi. But I need a common denominator, so 2 pi is 6 pi over 3. That's the same as 2 pi. All right, and then when I subtract my numerators, I see that I have cosine of 2 pi over 3. So we say 8 pi over 3 and 2 pi over 3 are coterminal angles. And from a previous video, we know how to evaluate this. We're going to find what quadrant 2 pi over 3 is in. And if here is pi, then we're 2/3 of the way to pi. 2/3 of the way means we're somewhere here in quadrant 2. Now, if you're really struggling with identifying what quadrant the angles are in, it could be kind of tough to think in radians. Go back to that unit circle and find 2 pi over 3 on the unit circle, and you'll see that it is in quadrant 2, okay? Now we're in quadrant 2, where sine is positive, cosine is negative. My reference angle is that denominator, and then go back and use that reference sheet. Pi over 3 conversion is 60 degrees. All right, so I have slash 60 degrees here. So we're going to do cosine of 60 degrees and make it negative. Cosine of 60 degrees is adjacent over hypotenuse, so our answer here is negative 1/2. Negative 1/2. All right. So I think that's it for our coterminals, because we're going to see a little bit more of them when we do the negative, and we're going to combine them with coterminals. Everything we've done here so far, you've seen in a previous video. It's just a more extended version of that, and now we're actually getting to some new material here, and that's going to be our negatives, okay? So I'm going to title the top of our paper, Negative Angles. Negatives. And then this is going to be the last thing that we're going to do together with our finding the exact value. Now, the only thing you need to really know about negative angles and evaluating negative angles is that it's going to be the same exact process, except when you open up and rotate, you rotate in the other direction. Okay, so instead of opening up to quadrant 1, your negative angles open downwards and they go clockwise and they rotate this way. All right, but just because our negative angle opens this way, our quadrants do not change. So this is still quadrant 1 where all trig functions are positive. This is still quadrant 2 where sine is positive. This is still quadrant 3 where where tangent is positive. And this is still quadrant 4 where cosine is positive. Okay, so the quadrants do not change. The only thing that changes is the name of the quadrantal angles. So when I open up downwards, now when I make a right angle, this is negative 90 degrees, which is the same angle as positive 270 degrees. They're coterminals. All right, and then when I open up to a flat line, this is negative 180 degrees, which is the same angle as positive 180 degrees. This is now negative 270 degrees, which is coterminal with 90 degrees, and this is negative 360 degrees. And then we're also going to take a look at those radians. This is negative pi over 2. This is negative pi. This is now negative 3 pi over 2. And this is negative 2 pi. Just like the quadrants don't change, the coordinate points also don't change. So at negative 90, this is still your coordinate point. At negative 180, this is your coordinate point. At negative 270, that's your coordinate point. And at negative 360, that's your coordinate point. All right, Let's jump into some example problems, and we're going to take a look, and oh my god, you guessed the directions. It's find the exact value. All right, I saw some decimal answers on your homework. There should be no decimal approximations. Exact value means give me a radical. Don't give me some estimated rounded off decimal answer. All right, we're going to take a look at the first one, and we're going to evaluate sine of negative 120 degrees. And I'm going to start putting those angles in parentheses. That way we know that there's no like subtraction sign or anything, that's a negative with that angle. All right, negative angle means we open up downwards, we pass 90, and then here we are, we're not yet at negative 180, so we're in quadrant 3. In quadrant 3, tangent is still positive, sine is negative. And then negative 120 is 60 degrees away from 180. Your reference angle is not negative 60 degrees. Going back to maybe like that second video we did on angles all the way maybe like a week or two ago, when we defined a reference angle, it was a positive acute angle formed with the x-axis. That's what a reference angle is by definition. So this is always a positive answer. So then now we're going to do sine of 60 degrees, and we're going to make it negative, and sine of 60 degrees here is going to be opposite over hypotenuse, and my answer is negative square root of 3 over 2. All right, let's take a look at another example, number 2 here. We're going to have cosine of negative 210 degrees. We open up downwards, we pass 90, we pass 180, and here we are lying in quadrant 2, where all students take calculus. Sine is positive in quadrant 2, cosine is negative. And then 210 is 30 degrees away from negative 180, positive angle there. And we're going to evaluate cosine of 30 degrees, and we're going to make it negative. So let's see cosine of 30 degrees. That's going to be adjacent over hypotenuse, and it's going to be the same answer as number 1, negative square root of 3 over 2. Moving on to number 3 here, we'll do another degree one before we take a look at the radians, negative 330 degrees. All right, we open up downwards, we pass 90, pass 180, pass negative 270, and here's negative 330 lying in quadrant 1, where all the trig functions are positive, and this angle is 30 degrees away from 360. So we're going to do tangent of 30 degrees, and that's going to be opposite over hypotenuse. That's 1 over square root of 3. But here's that little problem with that radical in the denominator. We have to go ahead and rationalize, and my final answer is positive square root of 3 over 3. Positive square root of 3 over 3. All right, let's take a look at another one, number 4. We're going to take a look at a radian example, and we're going to have cosine of negative 7 pi over 4. Okay, negative 7 pi over 4, so we pass here 2 pi over 4. We pass negative 4 pi over 4. We pass negative 6 pi over 4, and here's our angle lying in quadrant 1. You don't need to do it as quickly as I do, okay? Ms. Marflag's been doing this stuff for, a while, and I do it with my pre-cal kids, and I did it in college. So I'm able to, do these conversions really quickly. If you have to say, okay, this is negative pi over 2, this has a 4, which means I multiply numerator and denominator by 2. Okay, this is negative 2 pi over 2. I'm not quite there yet. Okay, I need the common denominator. This would be negative 4. Okay, take your time and convert denominators. And then you should see that it's in quadrant 1, where all the trig functions are positive, and that denominator is pi over 4, which is 45 degrees. Look at me using my beautiful reference sheet that Miss Marflag made for us on a pretty color paper. And then now we can evaluate cosine of 45 degrees and keep it positive. Cosine of 45 degrees is adjacent over hypotenuse. That's 1 over square root of 2. And then we run into that same problem as number 3. We go ahead and we rationalize, and we get positive square root of 2 over 2. And then there's an example with our radians. We're going to keep it going here with number 5, and we're going to evaluate sine of negative pi over 2. Those bells are going off in your head. I know they are. Negative pi over 2 is a quadrantal angle. We can go and take a look at our reference sheet and see that sine is our y value when it's a quadrantal angle. So my y value at negative pi over 2, okay, negative pi over 2 is down here, which is the same as 270. What's my y value at 270? It's negative 1, and then there's my answer for the quadrantal angles. And if you'd like, you could put y value down here, and some people like to put what it's equal to. This is sine of 3 pi over 2. It's the same answer. Okay, those are coterminal, right? Notice I added 2 pi. All right, number 6 here. Let's go back and do, let's do a degree one. We're going to do cosine of negative 60 degrees. All right, we open up downwards and we're not, yet at negative 90 degrees, which means this angle lies in quadrant 4 where cosine is positive and it's 60 degrees away from that x-axis. So we're going to do cosine of 60 degrees, which is adjacent over hypotenuse, and we're going to keep it positive, and there's our answer for cosine of negative 60 degrees. It's positive 1/2. All right, 2 more to go. We're going to take a look at number 7 here, and we're going to do sine of negative 315 degrees. We pass negative 90, we pass negative 180, pass negative 270, so our angle lies here in quadrant 1, where all those trig functions are positive, and 315 is 45 degrees away from the x-axis. So we're going to do sine of 45 degrees and keep it positive, and sine of 45 degrees is opposite over hypotenuse, and that's going to be 1 over square root of 2, and then we got to rationalize like we did in numbers 3 and 4, and we get positive square root of 2 over 2. And then one more, just to really, get these examples in for those negative angles. We're going to take a look and we're going to evaluate, should I do, yeah, I'll do another one. Tangent, another quadrantal, tangent of negative pi. All right, negative pi you could see is here at negative 180. You know it's a quadrantal angle, which means you have to check our chart. Okay, tangents are y coordinate over our x coordinate on the unit circle, y over x. So I need to find my y and x coordinate on 180. And my y coordinate is 0 and my x coordinate is negative 1. Or you can use my pretty picture from our reference sheet. My y coordinate is 0 and my x coordinate is negative 1. So we got 0 over negative 1, and that answer is 0. So you can't divide by 0, but you can have 0 in the numerator. All right, that's it for negatives, and now we're going to put everything together, and we are going to do negatives and coterminals. And then I don't have many examples for this one, but here we are putting together the 2 things we went over in this video, coterminals and negatives. And then take a guess what the directions are going to be. What? Whoever said find the exact value is the winner. Yes, we're still going with those directions. Don't worry. This is probably the second to last video you have to hear me say find the exact value. Okay, find the exact value. Ooh, went off page there. And here we are, we're going to take a look at number 1, starting this numbering all over again, now combining our knowledge of coterminal and negative angles. And we're going to have sine of negative 690 degrees. And then your brain's like, whoa, negative 690 degrees is a really big angle, so I need to find a coterminal angle, which means I need to add 360 degrees. Now, Ms. Marfleck knows her rules for integers, so she knows opposite signs, subtract and take the sign of the number with the biggest absolute value, or you can use a calculator, okay? And then when you use a calculator, you're going to see that you get sine of negative 330 degrees here. Now, you're able to evaluate this just like we did up here. We did tangent of negative 330 degrees. And I'm going to show you another way that you can do negative angles. If you want, you can go ahead and find another coterminal and make it positive. So we're going to add another 360 degrees, and we're going to get 30 degrees here. So all of these values are equal. If you'd like, you can just stop and not do another coterminal and solve this one like we solved above, or you can go ahead and do one more coterminal, and that kind of helps with solving for the negative angles. I wanted to show us how to think with the negative angles, so it is important to see this, but if you'd like, you really could have just added 360, add 360, add 360, add 2 pi, add 2 pi, add 360, add 360, and add 2 pi, and you're going to get the same answer. All right, so we're going to do sine of 30 degrees, and that's in quadrant 1 where it's positive, and the reference angle is itself, which is 30 degrees. So sine of 30 degrees here is opposite over hypotenuse, and that's 1 over 2, and there's our answer for number 1, positive 1/2. All right, number 2, and we're only doing 4, okay, so we're almost done. Stay with me. Number 2, we're going to do cosine of 7 pi over 2. Okay, so I see the denominator is 2, so I'm already thinking that this is a quadrantal angle, but let's first solve for that coterminal. So I need to subtract 2 pi, which is going to be 4 pi over 2. And when I subtract those numerators, I see that this is cosine of 3 pi over 2, and my instinct was right, this is a quadrantal angle. With quadrantal angles, cosine is our x-coordinate. So I need my x-coordinate at 3 pi over 2, and my x-coordinate at 3 pi over 2 is 0. And there's my answer, 0. All right. Oh, I should have made that one negative. That's not really with the coterminals and the negatives, Miss Marflack. That's okay. Maybe I'll do it here. 2 part A. This should have been negative. This is the problem with just making up problems on the fly, but this should have been negative, and then it's the same process. We find our coterminal angle, and we'll get a different answer here. All right, but I'm doing another practice problem where it's a negative. So I did lie before when I said we only had 2 more, because now we're doing 2 part A. Okay, so negative 7 pi over 4, we find a coterminal. This is going to be the same as negative 3 pi over 2, cosine of negative 3 pi over 2. And then I can add, if I'd like, 1 more 2 pi, and that's going to be cosine of pi over 2. It's going to be the exact same answer. All right, you can see here at negative 3 pi over 2, it's the same as pi over 2. So I'm looking for that x-coordinate at pi over 2, and I can see my x-coordinate is 0. All right, so there's another example. Maybe we'll just do one more, number 3. Let's see, then I gotta make it a good one. Okay, I'm gonna make it this one. Tangent of negative 29 pi over 6. Okay. So we see negative 29 pi over 6 is way past 2 pi. So we're going to add 2 pi, which is 12 pi over 6. And then when you add 12 pi over 6, you should see that this is negative 17 pi over 6. All right, and then I got to keep going. I'm going to add another 2 pi, which is 12 pi over 6. And then I can stop here if I'd like and see that this is negative 5 pi over 6, and we know how to evaluate this from above. Or I can just go one more time and add that 12 pi over 6 and find another coterminal, and this is tangent of 7 pi over 6, which is in quadrant 3, where tangent is positive, the reference is pi over 6, which is 30 degrees, and then we're going to do tangent of 30 degrees and keep it positive, and we have opposite over adjacent, and we got that 1 over square root of 3, and we go ahead and rationalize, and we have square root of 3 over 3, and then there's our final answer. But we could have stopped here if we'd like, and then used our rules from above. All right, that's it for today. We're finished with exact values. Your next video is going to be a test review, and then your next assessment will be a test, okay? In this video, we went over coterminal and negatives. We quickly reviewed some exact values from 0 to 360 degrees from a previous video. Then we did some more coterminals that we also did in a previous video. We, for the first time, saw negative angles where we just went in the opposite direction, and then we put coterminal and negative angles together. Email me if you have any questions and get to work on that homework.